Hello, and welcome to this module on storing and processing data in Azure. In this module, we're going to talk about data as it's a critical component to all applications, and the cloud's no different in that regard. However, in the cloud, we can take advantage of all of the hardware in those data centers and the scale, so we'll talk about some of the prime characteristics of storing data in the cloud. I'm going to show you the variety of data storage options that you have in Azure for different types of data and for different usage scenarios that you might have in your applications. We're going to then move to processing data, or thinking about moving data between systems, ingesting data into your data stores. And some of that is going to be around preparing for analytics, which we'll talk about in the next module, where we need to be able to ingest and store data in a system that can be used by the various analytics tools that we might choose in our solutions. Now, when we talk about databases in the cloud, there's a number of characteristics that come to mind. They need to be scalable. We talk about cloud scale all the time. Being able to handle burst loads, being able to handle large amounts of data, and being able to handle large amounts of traffic or interactions with the database. They need to be available. We need to have a reliable backing store for our data that we know is going to be available 24/7. And they need to be global. One of the benefits of the cloud is a set of global data centers that we can take advantage of, where we can store our data in the right region or the right country that's close to the user or that falls under our compliance and regulations. All the different options that we're going to talk about here have the ability to fit these characteristics. Azure solutions for storing data are built to scale, and they're built to be highly available, with many of the offerings writing your data in triplicate every time you save to ensure that availability. And of course, with all those data centers, there's a number of options for global scale with our applications. Another factor when we look at cloud-based databases or data storage is that you have self-managed options. This is probably what you're familiar with. In the cloud, we can provision a virtual machine or container that's running a database software service that we can then manage. This might be Cassandra or MongoDB or Relational Database. There's many predefined images out in the Azure Marketplace where you can simply go and provision the container or virtual machine, and it already has the software installed and ready to go. In these scenarios, you're going to manage the compute, whether that's a VM or container, and the disks, and all the other pieces that go along with that. And that's why I call this self-managed. It really is you taking advantage of the data centers and the infrastructure to create and manage your own instances. So that means you're going to be responsible for patching those containers or virtual machines as well. But we can truly take advantage of the cloud with service-based data storage. Here, we can provision an instance. Rather than a machine or a container, we say we want an instance of, say, a relational database. We still get to choose the scale characteristics. How performant do we need this to be? What do we expect the load to be? How much data are we going to store in this instance? But the benefit here is that it's managed by Azure. So you don't have to do patching. You don't have to manage the actual infrastructure for this. You focus on storing your data and making sure the data service is going to meet your needs. And you get the added benefit that you don't have to worry about patching, because it's going to happen behind the scenes for you, and you get to take advantage of having the latest and greatest and most secure backing environment without having to manage that yourself. Now, of course, in Azure, we have relational databases. And these are probably the kind of database that most people are familiar with. So we have an Azure SQL. This is SQL Server in the cloud, if you will. But it actually has a variety of different options for the whole continuum of scenarios. You can have a managed instance that allows you to very easily migrate from SQL Server on premises. You can take advantage of Elastic Pool or software as a service, where you might have a lot of different databases, but you want them to all share the same resources because they have differing usage patterns. So it's really optimized for different cloud scenarios. We also have other relational databases that are available. You have MySQL, MariaDB, PostgreSQL, and all of these are available in that self-hosted or service-based model. So you can create a virtual machine or container and run any of these, but they all also have a service-based model where you can go out and provision an instance of this and focus on your application development and your data storage. And again, all of these are built for the cloud, built to be scalable, available, and global in their deployments. In addition to relational data, when you start building applications, you have other data storage options that might fit your requirements. We have table storage, which is a key value storage. You have unique keys to identify the set of data and a set of properties that go along with that, or values that you can store. We have blob storage if you need to store large objects such as files, maybe image files, PDFs, or other documents. Can be virtual hard drives that you can store in blob storage. And it's built for the cloud and for the web with all sorts of things like caching and metadata that you can store around those files. We have Azure Queues for short-term data storage of messages that you need to pass between application nodes. And there's also a Redis cache and other caching options for that in-memory storage to take some of the load off of back-end storage, to save on costs in some scenarios, and to improve performance. I mentioned with the self-hosted options that you might want to provision a MongoDB document database in, say, a virtual machine. And you can certainly do that. There's options for Cassandra and Neo4j, for example, if you wanted to do a graph database. So a variety of different styles of data storage, from document to graph and column, that you can take advantage of as a self-hosted service. If you go looking for that MongoDB or Cassandra or Neo4j in a service-based environment, you may have a little trouble finding it, but that's because all of those things are encapsulated in Microsoft's Azure Cosmos DB. This is a very unique database offering in that it provides a multi-model storage capabilities. So that means when you create a database in Azure Cosmos DB, you can choose to have it be a graph database. And you can use the Gremlin API to go against the graph database. Or you could store it in a table storage model, and you can use the different Azure SDKs to access the data just like you would in table storage. You can set it up as a Cassandra instance, and you can use the Cassandra APIs to interact with your data store. Or you can do a document database, and you can choose to use either the MongoDB SDK and protocols to interact with that, or Microsoft's API to manage documents through their interface. So you can see that this gives you a very flexible model for how you're going to store your data all in one offering that is a service-based offering. One of the reasons that you might do that is that in addition to being multi-model, Azure Cosmos DB is a globally distributed database. That means you can have multiple masters in different regions. You get low latency synchronization between the different nodes. And best of all, you get 5 different consistency levels to choose from. Usually when you have this sort of a system, you have to make a trade-off between the immediate consistency with slower performance or eventual consistency with faster performance. But you get a sliding scale with Azure Cosmos DB of 5 different levels to fit your different scenarios. So when using Azure Cosmos DB, you get the flexibility of choosing the data model and the APIs that you want to use to interact with the data store, and you get this amazing back end of the globally distributed system that's built for the cloud. And finally, when I talk about data storage, I want to talk a little bit about Azure Data Lakes. And here I'm referring to version 2. And this gets us moving toward analytics because this is a large-scale data storage built for analytics and analytics tools. It's built on top of Azure Blob Storage, but it has 2 different access models, file-based or blob-based. And when I say 2 different models, they're not just layering one on the other, they've actually optimized for both so that analytics tools can use a file-based model to access the files or the blobs that you have in this data lake and get the same level of performance as a blob API. So you get the advantage of blob storage and all that goes with it in terms of the scale, the availability, and resilience, as well as being able to take data and put it into an archive or cold storage that you don't access as often to reduce costs. So you can see that with all these different options, they've been purpose-built for different scenarios and to address the needs of building cloud-scale applications and analytics. Let's talk a little bit about data processing, because while we have all this data stored, where does it come from and how do we move it? Sometimes the data is just going to come from your applications, but other times you need to ingest or process that data into the system. And for that, we have event hubs. This is a highly scalable ingestion model for taking messages and data and putting it into your data storage. Now, you can natively put that into data lakes or blob storage, but you can then move that data if you need to. And as I said, this is built to scale so that it can handle things like telemetry data or just vast quantities of data from devices and systems that are all sending data to your hub. We also have Data Factory for moving data or doing extract, transform, load type processes. If you're familiar with SSIS or DTS in SQL Server, you can think of this as a cloud version of that, but it tends to go beyond that. It is really all about taking data from disparate systems and even different clouds, cloud providers, and loading it, transforming it, and being able to then process it into other systems. We'll look at just a few examples to help make sense of how these might fit into applications. And one may simply be a cloud web application that you're building for the cloud. You might store some of the core data in Azure Cosmos DB using a document database, maybe your product catalog or some other data that fits with that style of data storage. Additionally, you might store some data in table storage. Maybe you've got log data, or you've got comments or reviews or other type data that's going to be very large, but you can index it and pull off those rows and the specific values that you want to see. And finally, you might take advantage of blob storage for your images. It's going to allow you to store these in a globally available storage option with the ability to do caching and other sorts of optimizations in front of that blob storage, so you can get the best performance in your application and for your clients. So in just a simple web application, you might have a variety of different data storage options in use. Now, another example is that you may be migrating a web application from an in-house set of web servers and database servers, and you want to pick it up and move it to Azure. So you can do that and use Azure SQL as your relational data store, and even take advantage of the different offerings under Azure SQL to make sure you get the best compatibility. Likewise, in a migration scenario, your web application might be accessing files through the normal file APIs, so you can take advantage of the Azure storage system and the Azure files that sits on top of that to give an SMB view over a share that your web application can access. This allows you to continue using the same file APIs, simply change the path in most cases, and because it's in a storage account, it can be available from all the different nodes or instances of your web application as you scale. And finally, if we look at an example of data processing, you may have some data in your own data center on premise that you want to be able to extract, or you might have data in another cloud, something outside of Azure where you've got some data stored in another blob system, log files, or other data, and you want to be able to pull all that in and use Azure Data Factory then to process it. So you can configure Data Factory to pull that data from those sources, and then it can send that data off after it's transformed it, maybe to an Azure SQL database or a data lake where it's ready for your applications or some analytics to process it. Data Factory has the ability to connect to all these different data sources to pull data and push data and do all of those transformations in between. So as we've looked at the storage options, you can see that there's a variety of different options. And I hope I've given you a sense through the explanations and the examples of how you can take advantage of those different storage capabilities for different application requirements. If you can, I'd recommend you take advantage of those cloud-managed or service-based databases so that you can get out of the business of managing the infrastructure and the database server installs and focus on the databases themselves and working with them in your applications and analytics. As you think about and plan for analytics, recognize that there are things like data lakes that are specifically built and optimized for analytics tools, and look at how that might fit into your solution in order to meet your analytics needs. One of the great things about Azure is that in addition to all the different data storage options, all these data processing tools are also available and integrated into your solution. Whether that's Data Factory or the Event Hubs or a variety of other tools, they're all there in your Azure subscription and available to work on all your different data sources and stored data to build your applications. And next up, we'll look at data analytics and some of the tools that are available for you in Azure.